And so I welcome everybody joining us today. And one of the reasons we are doing this webinar is when PUSH, the Presidents United to Solve Hunger, and the Hunger Solutions Institute participated or conducted a study on open data for PUSH universities. We found that a lot of faculty across the country, not just here at Auburn, are not very well prepared in being able to share their data and creating data management plans and implementing those plans once the data is received. And so with that, we've started conversations with Allie, who is a data librarian. And in the process of us doing this study, she was a brand new hire. So we got to know Allie, and it brings a interesting perspective in being able to help faculty in that prior to coming to Auburn, she was a researcher, but she also comes at it from a librarian standpoint and a data management standpoint. So she has the right mix of experience and skills to help faculty. And so we asked Allie, and she very thankful that she agreed to do this presentation. And the idea is with this is we want to look at some skill building for faculty, graduate students, and other people associated with research, including people who are following the grants and making sure that we're compliant with open data as well as data management. So Allie, I'm going to turn it over to you, and if you will tell us just a little bit more about yourself, and then we can get started.
All right, well, good afternoon, everybody. So my name is Allie Krztos. I am the Research Data Management Librarian at Auburn, and my background was originally in biological sciences, ecology and evolution. That's a very certainly data collection intensive field, and I like to joke that I was qualified to be the Research Data Management Librarian because I've made all the mistakes that one can make with data management and done all of the things that you're not supposed to do. So this is an area that is rapidly developing and that we're all just learning about day by day. So lots of information is constantly coming in, and the purpose of my giving you this presentation today is to catch everyone up on some of these trends, particularly in the area of open data, which is data that is freely reusable and can be mixed into different projects and essentially helps everything to move forward more quickly because anybody is able to make use of it. So I'm going to go ahead and start the presentation. And can you see the presentation now?
Yes, we can see.
Okay, great. Well, so very briefly, what I hope to cover today is what open data is and under what terms it's typically released. I've got the word licenses there, but as we will discuss, there's actually another classification that isn't entirely a license that's probably best for what we would consider truly open data. How you can, when you're drafting a data management plan for perhaps a grant that you're applying for, something from the NSF or the NIH or many, many other organizations now that use data management plans, how you can write about your data in such a way that you can convey how you'll comply with any open mandates the funders may have. And finally, since there's already lots of open data available, how will you find open data that you can then use for yourself, use it in research, use it for simply information purposes, anything that you can think of. So that's what we're going to cover today. So first, I just want to talk a little bit about what open data is. So data sharing, in a general sense, is not new at all. The most straightforward method of data sharing is, of course, by the publishing of scholarly articles, but a lot of times the scholarly article doesn't contain the full information, the full data set that was used to actually arrive at the conclusions, or it may be locked up in a table or some other kind of static image that isn't terribly useful. So what researchers would do is they would get in the habit of sharing data with each other, typically informally. In the old days, they might be actually mailing spreadsheets or floppy disks or something along those lines. So data sharing itself is not new, but then and now, most of that data sharing was very ad hoc and very individual. So within the scientific community, you might have somebody that you know very well and they've published a paper, and you say, oh, wow, I'm really curious to see how you got to that, but I couldn't quite follow from the analyses in the paper. Can you show me sort of the full data set, the entire body of information you used to get there? And the other scientist might say, sure, I will just send it to you. The problem with that, that's not a problem, but it's just that in this instance, data sharing only follows the network. It only stays sort of within the secret club of the practitioners in this field. But there are many other stakeholders who have an interest in that data. First of all, if it is a published work, then verifiability sort of demands that the data be available, at least on request. But thinking more broadly about something like public accountability or citizen science, or simply the fact that many of these research projects are publicly funded and can, in a sense, be said to be public property, open data, data that is available without this mediated sort of personal connection or network, is what we are going in the direction of. So the big thing to keep in mind about open data is that unlike data sharing that went on before, it does not depend on a personal connection. It does not depend on actually contacting the author or the person who created the data set or assembled the data set or incorporated it into the paper. It's designed to be able to just occur with the person who's found the data gaining access to it without having to actually go through that process. And taking it even one step further, truly open data, in the purest sense, accessing it would not involve human interaction at all, because you can actually crawl or scrape open data providers. They may have an API. So it then turns into a purely machine-driven process that no longer even involves searching. And once you know sort of what data provider you're interested in, once you've made that connection, then that's when you can start incorporating, say, a script that will pull data from an API on a periodic basis. Now, that doesn't have to happen. It can still stay entirely in the realm of a person going to a data repository and downloading the data. But when data is open, it adds that possible dimension of, okay, now this can be done by script. The most important thing to understand about open data is simply that shift where it's no longer locked within a network, only open to other practitioners. It truly is available to the public, to any and all comers. Part of the reason that this shift came about was from a memo that went out in 2013 from the Office of Science and Technology Policy. So this is a federal body. And in 2013, the OSTP sent out a memo that said that the data associated with federally funded research has to be made publicly available because these investments are public investments. And so it just didn't seem right for data generated in the course of work supported by federal funding to then be locked away, say, in a journal article or in these networks between practitioners. And the general guidance for that is that within 12 months of the publication date, of perhaps an associated article or a report or something along those lines, within 12 months of that, those data that are associated with it have to be made available. Now, there are many caveats to this. There are many reasons it doesn't happen. There are some reasons that it doesn't happen quite in a way that we would consider open, and I will go into what that means in a moment. But currently, the enforcement of this is really uneven, and I wouldn't even necessarily call it enforcement, but this is the underlying policy guidance that explains why the shift towards open data is occurring, at least for federally funded research. Now, allowances are made for something like the protection of human subjects. Obviously, if you're doing sensitive research on perhaps somebody's health or a vulnerable community that they may be part of, or even just in general, we don't want to be spreading people's personal information and allowing them to be identified all over the internet. So it's absolutely reasonable to, and in fact required, to keep human subjects safe. Sometimes information is proprietary. There may be contracts, other kind of IP to work out. And there are also other countervailing reasons that have to do with sensitivity of other information. For instance, in my own field, if you have a very endangered species and, for instance, it's the last one or two of this particular kind of tree, you don't necessarily want to say, hey, there's the very last tree of this particular rare species in this exact spot. So in those instances, it is understood that this information will not be publicly released. However, all of that said, the movement is absolutely towards expecting that within 12 months of publication, the data associated with these federal projects will be released. Now, in order for data to be open, it has to be publicly available. But not all data sets that are publicly available are actually open. Publicly available is a condition for open, but it does not completely satisfy what we would understand open data to be. In order for data to be open, they also need to be fair. And FAIR is an acronym that obviously it has a meaning on its own, but it stands for findable, accessible, interoperable, and reusable. And to just go through really quickly what that means, you'll see that just putting the data out there, just posting it to the web, is not fair, and I would also argue is not open in the true sense of the word, because when the data is fair, it is in its maximally useful state. We want data to be open so that it's actually a contribution to research. So what is fair? Fair data is findable. Findable simply means you can get to it, you can discover it. Data is everywhere, and it's very difficult sometimes to actually know what exists, much less where it is. So in order for data to be findable, it has to have rich metadata so that, for instance, a discovery service, a search engine, something like that, will actually find it. Those metadata have to be open, so the metadata themselves have to be available so that, for instance, Google is a bad example, but it gives you the idea of what I mean by this. A search engine will become aware that this resource exists and will point to it. It's also very important that there's a persistent identifier for this data. So a web address by itself is not really a sufficient indicator of where something is, because pages get moved and things change, and if you've ever hit a dead link, you know what the risks are depending on a web address. So DOIs are probably the most common persistent identifiers that most people are familiar with. And so when a data set has a DOI, that DOI will always resolve to that data set regardless of where it lives. So those are some of the things that help data to be findable. Now, A stands for accessible, and you may be wondering, well, if I can find it, then that makes it accessible, right? Not exactly. You can find data in the sense of being aware of its existence, but once you get there, you may click on it and it may say something like, contact this person at this university to actually get the data. Then that would be an instance of data that is findable, but it's not actually accessible because you're not able to complete the process and get the data on your own. In order to be accessible, the data actually has to be retrievable once you get to the place where it is housed. Another reason that data may not be accessible is if they are in a format that is not readable or not otherwise usable by the person who's trying to get to it. So that actually leads us to the interoperable part of FAIR data, because in order for data to be interoperable, it's got to be something that you can actually open, that you can actually use and manipulate. So for instance, a data set that's not particularly interoperable would be a static table in a PDF. You can look at it, but you can't do anything with it. On the other hand, if you had, say, a delimited text file, what you might think of as an Excel spreadsheet, but actually just a plain text file that has the rows and columns and can actually be read by any program equipped to deal with plain text, now suddenly it's interoperable and you can do a whole, any kind of analysis you might want to on it. Reusable is the final aspect of FAIR data, and that really cuts to the heart of open data, because when data is open, when it is released to the public without sort of conditions upon it, then reuse becomes simple. Reuse becomes increasingly likely. And that's the purpose of doing all of this. We don't just want people to see the information, see the data. We want them to actually be able to do something with it. So, for instance, reusable data have clearly delineated terms of reuse. It should say specifically what conditions the data are released under, what they can be used for, what they shouldn't be used for. And also, to go back to, we discussed metadata for F, for findable data. Metadata is equally, if not even more important for reuse, because, for instance, if you don't know how something was measured, if you don't know where the data is from, if you don't know any of the things that make data make sense, which is typically what we call its documentation or its metadata, you will not actually be able to do anything with it. So we don't just want our data to be open, we want it to be fair as well. So if you are going to deposit data and truly make it open, perhaps in compliance with a federal mandate, or perhaps just because you think it's the right thing to do, because you know that making your data available will generate increased interest in your scholarly work and make it more trustworthy and more robust, there is a fair amount of work that goes into actually making the data ready for deposit. The metadata and the documentation, again, really have to meet that standard, that R reusability standard. But even so, even though I said that the whole process is supposed to be unmediated and not require human intervention, things happen and questions arise. And so it's very important that updated contact information for the responsible person for that data set stays with the data set. There should always be email address, phone number, institutional address if applicable, and it can be tricky to keep that up to date, but that is something to keep in mind too of why the documentation needs to be good, because say somebody retires and that's their contact info that's listed with the data set, they can't be contacted, so hopefully the documentation is sufficient to actually allow the data to be used. We discussed at the beginning some of the reasons that data couldn't be or shouldn't be completely open, including human subjects research. You can actually make the results of human subjects research open, but it's very important that it goes through a de-identification process first. And there are specialists out there who understand very well how to de-identify data. It can be important to consult with people like that because you may think that, for instance, you've gotten all of the identifiers out of your data set, but it may be possible to re-identify somebody from incidental things in the data set that aren't specifically an obvious way to link them back to their identity. So if you plan on making human subjects research available, it's definitely worthwhile to get in touch with, for instance, the folks at the ICPSR, which is hosted at University of Michigan. They will answer those sorts of questions. And another thing to keep in mind, speaking of asking for assistance, is that when it comes to formatting prior to the data deposit, again, with interoperability being a concern, the file formats that you did the work in and that you created the data as originally may not be the best formats to actually preserve and save them for the long term. So librarians and other information professionals, perhaps in IT, can give advice on, for instance, having something in an Excel format, which is proprietary and not really suitable for archiving, versus, again, these text-based formats that can be handled by programs for years to come. If you think about the pace of research, there are times when it seems as though it's extremely quick, but the pace of research is not equal to the pace of technology. And we at times have difficulty reading data sets in formats even from 5 years ago. Then you suddenly have a 10-year-old data set and you can no longer get into it at all, and that's a disaster. So we really want to try to avoid getting in a situation where things from the same decade can no longer be reused. So now you've got your data set prepared, you're ready to deposit it, perhaps you have deposited it, and the question is, what are the terms that actually facilitate the data being open? Many people may be familiar with Creative Commons licensing, which is very clearly marked on open access articles. It typically says something like CC BY, which means that the only requirement for using the contents of that article is that they be attributed. That's the BY. You just have to say who created it, who the author is. There are other licenses such as CC BY non-commercial, CC BY share alike. I won't go into those. The problem with the CC BY license for data, because it makes a lot of sense for articles, but for data, there's a wrinkle in that facts can't be copyrighted. If I take a look at the temperature outside, if I have a thermometer and it says that it's 74 degrees, I can't copyright the fact that it was 74 degrees in this location today. So the CC BY license, even though it makes sense intuitively, is no longer the recommended license for the release of open data. So then you might say, all right, what should I do instead? And it's not exactly a license, but CC0, or so-called no rights reserved, is now the recommended classification for data sets. Now you might go, wait a minute. It's very important that I receive credit for the work that I did. If I release my data set as CC0, that's effectively putting it out into the public domain. Doesn't that mean that anybody can just use it for anything without any conditions attached at all? Not exactly. When you're operating in a scholarly community, a research community, or even any other party to the system of, say, public accountability, such as journalists, there are norms associated with actually attributing your facts. And so if somebody uses your data set, they may not be legally bound to attribute you under the CC0 license, but they are bound by the norms of the scholarly community. And this is very important because effectively, those are the norms that are operating now. Those are the only things keeping people from simply taking facts or other information to suit them now. So it's really the same system. The legal, not even requirement, but the extra sort of legal impetus that a CC BY license would provide is not worth the risk of what can happen if you don't have a very clear sort of no conditions attached rider on your data. I was very interested to understand why CC0 had become the preferred, not even license, but simply conditions for the release of open data. And what I discovered is that even something like CC BY, it creates ambiguity, because if facts aren't copyrightable, but you have a copyright effectively on the parts of the work that are copyrightable, which is what the BY would apply to, then that's a bit of a mess, because suddenly you have essentially two different terms of license or two different interpretations in the same work. I won't go into the sort of legalistic explanations for why, but the Creative Commons Wiki explains it fairly well. And I, for one, was satisfied that when you have something released under CC0, that does not in any way release the next user from attributing where they got the information, because that's just due diligence. So basic due diligence isn't going anywhere, and we don't want to inadvertently hinder the reusability of the data that we're trying to make open. So speaking of citation and attribution, data citation is not completely standardized yet, but there are several accepted practices that go into it. And the same organization that has explained fair data and has laid down those principles also has created a basic framework for data citation. And it's much the same thing. It just ensures that you're going to be able to get back to the original source of the information. It's going to be in a defined place, and all of the information in the citation is going to be sufficient to sort of recreate the provenance of that data. So here's actually an example. I think that this is an excellent practice when you release your data, is to actually have a model or a sample citation that can be copy-pasted. This particular example that I've got here actually gives the instruction to cite both the publication associated with it and the data set, and that's something that you're seeing very commonly now. But what's important to notice is that the citation's already been created. If you're using any kind of a reference manager, you can simply input the information from the citation and it will format it for whatever paper or report, whatever the style is that you need, but it's already provided there to give somebody a start. That saves a lot of time and a lot of confusion for the people who are ultimately reusing this work. One of the most important parts of the data citation is that persistent identifier. So you can see there for both the article and the data set associated with it, that DOI is displayed prominently at the end, and you really need to have that, because that's going to guarantee that whoever's trying to trace back that citation will get to the data set, even if it's moved, even if it's hosted in a different location. Many people are going to be interested in how this information can be worked into a data management plan. Now, data management plans, again, relate back to this OSTP memo, but they even go back further, because organizations such as the NIH and the NSF actually had these public access requirements prior to the OSTP memo. So in order to ensure that people are complying with the requirements of this federal funding, the data management plan became part of the grant application itself. Although there's some variability in how data management plans work, if you learn the basic NSF format, that's essentially going to work for any DMP, unless you have some kind of very specific requirement. I'm guessing for a nonprofit or otherwise private funding source that's not the government. Definitely anything for the government, the NSF template is going to work well. So what does that look like? You've got a maximum of 2 pages. So you cannot exceed 2 pages or it will take away from the rest of your narrative. But some people even struggle to fill up 2 pages because they just don't quite understand what goes into a data management plan. The complete construction of a data management plan is a topic for another day, but I do want to draw everyone's attention to the 4th aspect there of data sharing, protection, and public access. So that's where open data and making data fair and the terms under which data is going to be released, that's the section where those things would be incorporated. So for instance, if you were going to make your data open, you would write in the data management plan that on such and such date at the conclusion of the project or after publication of the manuscript or whatever conditions you have, the data will be placed in this repository. That you should have some idea of where the data is going to live. It ideally should be a trusted repository that has, DOIs and versioning and persistence. You don't want to choose a repository that's likely not to be there in 2 years. And it can be difficult to decide which repositories are most appropriate, but in general, long-standing disciplinary repositories that are recognized by the communities that use them, those tend to be fairly safe. So you would put that information into your data management plan, and you would also say something about, prior to that, how the data is being prepared throughout the stages of your research for that eventual deposit. So those would fall into other sections of the DMP, such as the data and metadata formats and the form that the storage is going to take, because it's possible that data that's dependent on a particular storage configuration would have to, you can't, for instance, just take a SQL database and plug it in somewhere else. So you might have to write about the steps that would be taken to sort of extract the data and get it into the repository. These are all this is just to get you to think about some of the things that typically go into a data management plan so that you can be prepared for it. I just want to say very briefly that a lot of people treat the data management plan as a checkbox, and I understand the temptation to do that, but the data management plan is actually an opportunity to save yourself a lot of headaches down the road, especially if you are going to be subject to a public access requirement because of your work's funding. And so I really strongly suggest that as you're filling out the DMP, you consider these questions that could arise before you actually have to do the work, and also consider adding to the budget for the expenses in time, in perhaps storage costs, and occasionally deposit costs that go into creating publicly accessible and ideally open data. You don't want to be rushing at the last minute to figure out how you're going to comply with these access requirements. The roles and responsibilities section of the DMP can really help to clarify some of these issues. It's actually rare for the PI of a grant to be doing all of this work themselves. It's frequently a postdoc or a graduate student or some other member of the lab who's taking care of these data management, data housekeeping tasks. The PI is typically the one who is in charge of making sure that it gets done, so the PI should at least be verifying that the data was deposited in the repository where they said it would be deposited, and that the metadata is in order, and that contact information is in order. But I want to emphasize that this is not essentially just one more thing to pile onto the PI. There is support available, and outside of the lab group, there are university support staff that are meant to assist with these things. At Auburn, here in the library, we provide data management support, data deposit support, and it's also very helpful to talk to your unit's IT. So the distributed IT manager can help you with getting secure network storage, understanding the best preservation strategies so that you don't actually lose your data, that it's soundly backed up. So it's worth talking to the folks on campus that are here in order to help with this process. So the last topic that we're going to cover, you may be sitting here thinking, well, I'm not sure about open data. I'm not sure if I can make my project data that refined. I'm not sure about the conditions that I want to release my data under. Those questions are worth revisiting and worth considering at a later date, but a lot of people are excited about the possibility that they can use the data that's already been made available and already is open for their work. So even if you're not a data producer, and even if you are not able to release your data openly, chances are you may have some interest in being a data consumer. And in fact, there are whole areas of study that depend greatly on, for instance, government data. Where would the field of economics be without the open release of government data in order for them to test hypotheses about, for instance, the effects of policy? So open data is something that you can incorporate into your work now. And the question is, where can I find open data? And how will I be able to actually acquire it and incorporate it into my work? So it's not necessary, as I said, to know exactly what's out there and to know exactly where it lives. Formerly, data was very siloed, and unfortunately, in some cases it still is, but more and more, you can search for data in multiple places at once, and that greatly reduces the difficulty in actually coming upon data sets that can contribute to your work. The best way that I think to start with data when you're not sure what's out there or what you really want is to go to one of the large aggregate portals. And data portals search many, many, many different records, often in different places at a time. re3data.org is a huge data portal registry. And if you go to re3data, it will actually get you started on finding the kinds of data sets that you might be interested in and give you a place to sort of get a foothold. When you're reusing data, when you're intending to incorporate it into your project, you do need to pay attention to the terms of use, because there's lots of data that's available and it seems as though it's open or it should be considered open, and then it actually has some rather sticky or ambiguous terms of reuse. So you want to be aware of those issues before you write an incredible article making use of this data set. And again, if the data provider is doing their job, there should be a contact link, an email address, something where you can actually contact a responsible party and find out the answer to your question about what their intention is for reuse. Again, these are things you want to do as close to the beginning of your project as possible. So I'm going to just very quickly show re3data, show what kinds of results you might get, and that will give you a place to begin as you hunt for open data that could be pertinent to your work. So just to switch the screen, this is re3data.org, and that is the web address. So if you were to type that in, you would get here. You can see it's a registry of research data repositories. I think that this is primarily aimed at research data. So if you're interested in government data, you might actually want to start at the government websites. Certainly in the US, data.gov is an excellent portal. But for something like this will browse literally thousands of data sets at once. And so just very quickly to show how this would work, we pick a topic of interest here. Say we wanted data on oceanography. And this is 16 pages of results, 391 results of repositories that can be used to get all sorts of data: World Data Center for Oceanography, Scripps Institute of Oceanography Explorer. You would have to probably narrow this search or have a better idea of what would be of interest here, but this would definitely get you started. So this is the kind of first steps you would take to search for open data. Another good way actually to come across data is if you have a particular journal that you read on a regular basis, or any journal that you know of that has an open data policy, or that data has to be released with the article, you can go to that and browse to the articles, and they should link directly to the data set that underpins the article. Many times, those data sets will be stored in a repository that is accepted by the community, that is expected to be a place for this data to live long term. And so that's another good way to sort of, from the bottom up, come across open data, whereas something like Re3 data is more of a top-down resource. And also, don't be afraid to ask peers how you might come across something of use. How did they find data that they chose to use? And in general, what the accepted norms of the field are concerning data. And I do want to just come back to that for a moment as to some of the considerations that you may want to take into account. So when you're using open data, is the data source a static data source, or is it actually updated? If data is updated, is it going to matter which version of it you get? If it's historical data, if it's something that's happening on a particular day, the update is not going to affect you because it's not going to change what happened on that particular day. But if it's data that needs to be current or data that's constantly under revision, you might want to think about how you would deal with changes in that data set and how you would express the fact that the data may have been of one version when you actually pulled it and are now in another version, because it's very important that people who are looking at your work can see what you were seeing when you actually did the analysis. Data formatting is very important because, unfortunately, even when people have the best of intentions and make their data open, there may be something strange going on with their formatting. They may be relying on equipment that you don't have or software that you don't have. And if something is, for instance, in SPSS, that's actually great for social science data because it keeps a lot of the documentation together. But if you don't have SPSS, you might be out of luck. So format is an important consideration. Particularly with automatic scraping or pulling of data, say by crawling the web, quality control becomes an issue. And you don't want to go through an entire analysis only to discover that there was some kind of error introduced earlier on in the process. You want to catch those mistakes early, so it's worth thinking, who is going to do the quality control? And who's going to check to make sure that your own processes are running the way that you expect them to? Attributing the data. As I said, data citation is very important, and getting data citations linked appropriately is important. You want to make sure that, for instance, the people who are providing the data are still getting the credit for it, because sometimes funding depends on things like that. Repositories depend on being well known, being a trusted resource, and also, again, simply for good scientific practice, you just have to make sure that you attribute your data. So give some thought to how those citations are going to be constructed and make sure they're there. And finally, do check that there is a contact link or contact information, because there are times when questions are unavoidable, and sometimes you do end up making a great connection with data that you found that's open, and yet you find that it's actually the conversation with the data creator or the data provider that gives you the level of insight that you were looking for. So I know that from the start, the topic of this has been about open data and how that personal connection with the data provider isn't necessary anymore, but we're still social creatures, and we still tend to do better when there is some kind of communication with the data creator. So be open to the fact that you likely could be contacting the data creator or the data provider at some point. So you don't want to get to the point where you go, oh, I need to ask this question, only to discover that there's no contact info. So that is the end of the material that I have, and I will now take questions. And thank you all for attending.
Thank you, Allie, and I do encourage you to ask questions. We have several people on, and they're looking at this from different perspectives. I think some people are like in Office of Sponsored Programs, either in the Central University office or within particular colleges. We have some IT people, we have researchers, and some here in nutrition in the College of Human Sciences. And so everybody kind of has different perspectives, I guess, about open data and then also how to different ways of being compliant with these grants that are coming through from federal funded agencies or even some foundations that are requiring open data. Let me start my video. And so, but I have tons of things I'd like to talk about, and but if anybody else has a question, feel free to chime in. When you've been working with faculty and you've either some of your work prior to coming to Auburn or even here, have you seen where faculty have they themselves have found benefits from sharing their data? You know, like they're sharing their data because it's maybe being required on a project funding, but also benefits that come directly to faculty as a result of sharing data.
Yeah, I would love to talk about this because I've actually been presenting on that topic at other professional conferences recently. And I think that in order to really get the system robust for the long term, we're going to have to do a much better job of recognizing the data creators and the data providers, because at this point, it's a lot of open data is coming from, for instance, governments or nonprofit organizations that primarily exist to release information to then data consumers. We're still not quite where we need to be in terms of the academic community getting appropriate recognition, say, for the data that they release, but that is starting to change. And one positive development I'm noticing is that in certain fields of study, people who are making their data available and who follow these good practices are becoming more respected. They get more traction for their work. They end up having a higher scholarly impact. So there's scholarly impact in the narrow sense of, you know, number of citations or securing grants, securing publication in high impact journals, but there's also, and that can improve as a result of publishing your data. But there's also that broader scholarly impact where you become better recognized and somebody who is trustworthy in the field. And when your data is released, again, people who use it and who might have questions or who might need a more in-depth understanding of that information will come to you. And so that's generally what I would say is the benefit we've been seeing of releasing data is improved scholarly impact for the data provider and also tighter, more integrated communities of practice in specific disciplines. If I were to just give one example off the top of my head, I'd say the computational biology community has really kind of taken some of these practices and run with them. And they don't just make their data open in the interests of reproducible research. They also share their code and any other associated tools, software configurations that they're using to make sure that people are able to get back to the results the way that they've reported them.
And again, if anybody else has any questions, speak up.
Hey, this is Puneet calling from Biosystems.
Good. Yes. Go ahead.
Yes, I have a question for Ellie and maybe you. Who takes that liability if somebody uses your data and makes a decision, a negative outcome is seen? Who becomes liable then? So an example would be, suppose we generated some data that's useful for designing a bridge, and somebody then used that to design a bridge, and the bridge later on collapses. Who becomes liable?
That is a fantastic question. So thank you. So I'm not as familiar with the engineering field, but I know that there are, for instance, engineering repositories that have data that people then do use to design bridges and things like that. The thing about that is, as far as liability when things go wrong, that's on the person who used the information. When you make data available, as long as you're not deliberately putting out something that you know to be false, which is very, very rare and would be difficult to demonstrate, the decisions or the analyses or the things that flow from that data are on the people who are using the data, not the people who produce the data, because when you release something openly, and typically you can make this explicit as well, if you're not putting conditions on the data, you're not making guarantees about it either. You've outlined in your documentation how the data was created, you've outlined where it came from, then it becomes on the data user to do their due diligence. And so I would say if something bad happens as a result of somebody's data being used or misused, that's on the person who used or misused the data, not the creator.
And is there a place where it says that what you just said?
Typically, that's the condition of the open license. Data is made available essentially as is. Now, I will put in the disclaimer that I'm not a lawyer and I make no representation, again, with the not making representation of any legal ability on my part. If you wanted to know more about that from somebody who has a legal background, I would encourage you to seek out those personnel at the university. But generally speaking, they tend to look for worst case scenarios and they try to minimize any kind of negative aspect and miss out on the various positive aspects that come of, making data open and sharing it. And I have certainly never heard of a single instance of somebody making a decision or building a product on top of open data or any other kind of open information, and then that person ultimately getting in trouble. If such an example exists, then that would be, I would be interested to hear about it, but I have never run across anything like that.
Thank you.
Yeah, it seems to me too that where within the disciplines where the data is being shared, where the repositories are, for instance, the social science repository that Allie mentioned much earlier in the session, that those repositories have those kinds of things fleshed out. And so I'm thinking within the disciplines you would get a clearer picture of that situation. So.
But I will add that I think that that's a valuable question, because part of the purpose of open data is that we're moving the use of the data beyond the communities that would traditionally be interested in them. And so that is one thing that we'll have to grapple with, is when people are interacting with the data outside of the community of practitioners, how does that get sorted out? However, I would argue that that's exactly what we want. We want, for instance, citizen scientists who can assist in environmental quality monitoring, or people who are able to, hold their leaders accountable because there's data available that shows that what's happening in a community isn't what leaders were saying was happening in a community. So that's actually part of the benefit of open data, is that it's moving outside of these communities of practice. So I hope that we can perhaps look on the sunny side and see the long-term value of that happening.
Yeah. Thank you, Ali, and thank you, Anne. It was a good discussion.
Yeah, that was a great question. We have 3 minutes left, and I may ask Ali another question, but before, I'm just going to give you a little information on PUSH and some of our work. This webinar and the presentation will be recorded on the PUSH site. I left a link in the chat, and it's going to be under resources. And my guess is it may be Monday before I get the recording up. Also, coming up on April 25th, we are hosting another webinar, but it's really for those people who get USDA funding, because the Natural Agriculture Library has a repository called Ag Data Commons, and we'll be doing a webinar on that with National Ag Library representing or sharing what they their repository and the support that they give. So I'll put that in the chat. Just, one of the things you mentioned, APIs, and I think about all of the data when we look at weather data, what has happened over time with weather data that there are computer programs that now forecast really within an hour of what the temperature is going to be and what the rain possibility is going to be, which is really is fascinating. But really it's because the data was open, and then people came up with ideas of how to use it for public use. And so there's this possibility of doing that with all kinds of research data. But the biggest thing, in order for that to happen, that data has to be machine readable. And so can you just talk about the importance of, of having data machine readable, and
Absolutely.
And just downloading a data set and start working on it versus having a machine be able to read it?
Yes, absolutely. So I didn't go into this as much as I could have because I wasn't sure how many people wanted to go into the technical weeds, but machine readability is a big part of making data not only open, but as we said, fair. And the reason for that is the less machine readable, the less clean and refined your data is at the time of deposit, the less likely it's going to be that the users will be able to just slip it into their systems and make use of it the way they might otherwise be able to. When you have an API, when you have something that's open to be crawled and just have purely machine processes that acquire the data and bring it into the system that's going to be analyzing it, that greatly increases the possibility for reuse, the likelihood of reuse. It sort of greases the wheels of the system. So when it's possible, and I understand that it isn't always, because I do come from a field where there was a lot of, I guess you could say, boutique data or small scale data. When you can make it machine readable and when you can get it into an API, that's when I think the potential of open data really shines.
Great. That's a great explanation. We are at the top of the hour. I want to close this out. I left my email in the chat. If you have any feedback whatsoever you can give us, we really want to hear back from you, whether you think this is helpful. Would it be helpful to other people? Are there other ways that we can provide this kind of information? Do we need to go deeper in any particular subject, or, you know, anything you would like to share with me? I really appreciate you getting back and sending me an email. Thank you for your participation, and I really appreciate Allie taking the time to give us this this information and being able to cover it in such a way that it really goes across many disciplines and not just particular ones. And so you did a very nice job, Allie, and we really appreciate you today.
And I do just want to add, for people who are at Auburn, if you have questions pertaining to data, not just open data, but any aspect of data management, feel free to contact me, and I will just go ahead and put my email at the bottom of the chat right now so that people could do that. Okay.
Thank you again. And again, just let us know what you're thinking about this webinar. We appreciate it.